All right, good morning. I'm going to try to help you guys get started with the computational assignments. So this is the Computational Physics Handbook that's in D2L. Um, the first two sections, introduction, submission guidelines, you definitely need to read those. I'm just not going to read them to you today. We're going to start here on assignment one. Um, okay, so we have three goals. Set up a Python environment, analyze a Python script, and test three different physical models against the provided data set. So we will use Google Colab. So go to collab.research.google.com. I've already done that. You're probably going to have to create an account, or I suggest logging in with Google. I've already done that too. Go to File, Upload, Notebook. Okay, so I'm going to upload, browse, and then go to where you've downloaded the files from D2L. For me, that is in this folder. So our first one, it says we're going to get the curvefitting.ipy. So I'm going to open that. You will have downloaded that from D2L. It's in the same folder as the handbook. And the first thing it asks me to do is to change the name. So I'm going to change this to Comp Homework 1 Foreigner. Okay. And let's look around Google Colab a little bit. So Google Colab has text boxes and code boxes. So if I add a text box, I can type some text in here, and this is a text box, and then I can click close the editor, and now we've just got this text box. If I want to edit it again, I double click and I can go in here, and then when I'm done, I close the editor. Now I don't need this text box, so I'm going to go ahead and delete it. This file already has a text box here at the beginning, assignment 1, data fitting, and effective variance. Edit this text box and put your name here. Okay, I can do that. Okay, close the editor, and nice, might be nice on all of your assignments to have a little text box at the top saying which assignment it is and what your name is, although I've also got your name in the file, so maybe that's good enough. Okay, press Shift, Enter, or click the play button. Okay, so we've got some code already loaded in here. So it's asking us, I'm going to go ahead and highlight the code box, and I'm going to click play. And what that does is it runs this code. And here's the output of the code. It creates a graph with some data points and a curve fit. So then part B here goes through the code part by part. Hey, I'm recording a video. Oh, thank you. I love cookies. My students will love the fact that I am talking to somebody else during the video. Hi, students. Bye.
I was just dropping something off.
I appreciate it. All right. Okay, so this part B goes through the code step by step, and you'll see here user-defined inputs, and over here we've got user-defined inputs. So, and then over here, define the fit function, and over here, define the fit function. So this section will sort of take you through this code and tell you what it's doing. You don't have to be able to write this. Okay, right now, what you have to be able to do is use it. Okay. All right, and then we get to the actual problem. It says, you've measured the period of oscillation of a new nonlinear mechanical oscillator as a function of the mass attached to it. You suspect the relationship follows a specific power law, but you need to verify this against other possibilities. So the idea with this particular code is it's used for comparing data to a theory. So it says, here's your experimental data. Well, we need to put this experimental data into the Python code. So I'm going to copy that, and I'm going to come over here, and here's the experimental data, And what I want to do is take out the example experimental data and put in the real data from the assignment. So I'm going to Control V. Do I need to edit this? No. So I'm going to delete all this. And okay, for some reason it didn't copy. Copy. Paste. Really? It didn't like... Oh, I thought I could paste. I've done that before. Okay, x data equals np array. NP stands for NumPy, which is Python's numerical stuff. All right, so we're going to put in some data, 0.5, comma 1.0, comma 1.5, comma 2.0, comma 3, 3.5, 4. Yep, that's all correct. And we'll go ahead and add a comment at the end. Comments in Python start with a hashtag. This is the mass in kilograms. And then down here, my y data is going to be 1.6 seconds, 2.3 seconds, 2.7. Oh, I wish I didn't have to type this in. 3.1, 3.5, 3.8, 4.2, 4.4. Close that, and those are my periods in seconds. By the way, the comments are just for a human to read. The computer completely ignores that, but it's nice to comment your code so that you know what's going on here. Okay, these are my uncertainties, and I'm getting really annoyed that I can't copy and paste. So my uncertainties, the first set of uncertainties we're saying are equal to 0.005 times the x data. So what does that mean? That means that each uncertainty is 0.5%, 0.5% uncertainty. So we've set all the uncertainties to be a certain percentage of the initial mass. Okay. And then the second one says the uncertainties are all given as numbers. So we'll put those in 0.03, comma 0.03, comma 0.03, 0.03, 0.03, 0.06, 0.04, and 0.02. Okay. Next, it wants us to change the plot labels. Okay, so we can change the plot labels from period of a non-linear oscillator, and this is mass in kilograms, and period in seconds. Okay, and you'll notice this is red text. Those are text strings. So, you know, I could put blah, blah, blah here. And if I run this code, all I've done is change the data and the uncertainties and the labels. And, says I got an error. Didn't like that number. This is supposed to be 0.5. So let me run it again. Oh, got an error again. It didn't like my hashtag. In which line? Line 12. It didn't like my... Where is it? 0.5% uncertainty. It didn't like that I called that 0.5% uncertainty. And the reason is you need a space to create a comment. Hashtag space, blah, blah, blah. And then it'll ignore it. Okay. Another error. This is great. I'm getting good at errors. Okay. Really what it didn't like is that decimal point. Maybe you don't need a space. Okay. Try again. More errors. Well, I'm guessing that means 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7, 8. Yep, I figured I typed it in wrong. 0.3, 0.3, 0.3, 0.3, 0.6, 0.6. So that error was very hard to understand. Like, you read this error, what the hell does that mean? It's completely incomprehensible. But the only things I changed from a running program were up here. And it turns out if the number of values in the uncertainty is different from the number of values in y, it looks like that's going to give an error. God, I hope this works now. Oh, nope, because I made another typo. This is great. You guys are getting to see all kinds of mistakes. It's really not this hard. I bet you'll get it right your first try. Sigma has the incorrect shape. So it still thinks I don't have the right number of data points. 1, 2, 3, 4, 5, 6, 7, 8. Okay, that seems to be right. 0.005 times x data. That should be right. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3. Oh, that's a comma. Needs to be a period. I wonder if anybody saw that. God, that took forever. I'm so sorry. Anyway, I don't think you're going to have as much problems because you're not going to be recording a video while you do it. So let's see. The program ran after I changed the inputs. It didn't actually ask me to run the program yet. I just did that to test it. I'm glad I did because I made quite a few silly mistakes typing in those values. Okay. So now we want to test 3 different functions to see if they fit this data. Model A, a linear model, Model B, a quadratic model, and Model C, a power law. So we're going to test Model B. So here we go into the assignment tasks. So we're going to test Model B first, quadratic. Why? Because it's already in there. To ensure you've replaced X data and Y data in section 1 with the new oscillator data provided in part 3 above, do not run the code with the original example data. The example code is set up to test a quadratic model. The code is already set up to test the quadratic model. Let's see if we can find that in the code. Define the fit function. Let's look at this code. The fit function is a x squared plus bx plus c. Yeah, that's a quadratic function. Okay, so it's already set up to test a quadratic function. This section here is where we create the fit function. We define the function, ax squared plus bx plus c. We tell it that a, b, and c are fit parameters that the computer has to modify to make the curve fit the data. And then we give it some initial guesses for those fit parameters. And then the computer takes over and finds the actual values of a, b, and c that are closest to the data. Okay, so we ran the code. Great. We ran the code. We got a result. Okay. Add a new block of code. Okay. New block of code. Copy and paste the code into this new block. Okay. So I'm going to hit Control A to copy all of this. Control C, and then Control V, and I've got another copy of the code. All right. Test a linear model. Add the new block of code by clicking OK. Copy and paste the new code. Go to section 2 of the code. where we define the function, and we want to change it to be a linear function, ax plus b. Okay, so I can do that. A times x plus b, and that's it. So now my fit function returns a times x plus b, ax plus b. Okay, change the arguments to x, a, and b because now we don't have c as part of the equation. Okay, I can do that. So that's fixed this part. Next, we need to update the parameters, to be just a and b. Okay, that makes sense. And we probably need to update the original guess to only have a and b. So if I change the number of parameters, I've got to change all three of those things. Okay, now run the code. All right, so now instead of finding the best quadratic to fit the curve, it found the best straight line to fit the curve. Okay, and we're going to continue on and do part C and then answer some questions. So I hope that's enough to get you guys started and to see how we're going to use Google Colab and the Computational Physics Notebook to do these assignments. Eventually, you're going to have some questions to answer, and you want to make sure to put those in a text box for me. And then at the end, once you've done everything, okay, we're going to submit it. So to submit it, you're going to go to File, Download, IPyNB. So you're going to download that and make sure it's got the correct name, and then you're going to upload that to D2L for me to grade. Okay, that should be it.